Hi, we're the UPMC like the state reduction team by Edith, Josh, Ian, Ishwan, and Amanda, and we're working with UPMC Shadyside. So the problem we're facing is in 2022, 57% of patients at UPMC Shadyside stay longer than the CMS-defined geometric mean length of stay, which affects both the funding they receive for patient care and the volume of patients who can be treated. We must determine the causes of these inflated lengths of stay and delayed discharges in order to present recommendations for improvement.
Our goal is to locate areas causing the most substantial impact to inpatient discharge delay and uncover reasons behind the process bottlenecks to give recommendations and configure methods for future improvement. For our solution methodology, our team will analyze historical patient data to better understand the factors which affect length of stay and focus on meeting CMS standards and increasing profitability for the hospital. Our method is to use our Excel and Minitab to analyze the data, more specifically to compare with same diagnosis and compare with same physician and specialty. Finally, we develop a prediction model using random forests to give an idea about how new tools could be used in healthcare.
So we developed a few different deliverables for this project, the first of which is an inpatient process map to help us identify areas that serve as bottlenecks. That's where we found that the most significant source of delay was on consult turnaround time, so we focused a bunch of our analysis on that. And from there, we can develop some standardization recommendations. So this is a visual of what our process map looked like, broken down into 4 different stages. You can see highlighted in red are those specific areas of most significant delay.
And from this graph, you can see the red point here is sitting the dashed line, means the actual length of stay is longer than the geometric length of stay as in by CMS. And our goal here is to reduce the length of stay to make the blue regression line get back to the dashed line there. And in this plot, the ECDF on the left shows that the cumulative distribution of the length of stay, and it shows that in 75% of all cases, the group with the consult extend the length of stay to 2 times as the group without a consult. And the right graph here shows the frequency distribution, and with and without consult groups also shows that without a consult will shorten the length of stay. And in this case, we split the data into different DRG code according to different diagonals and use the actual length of stay minus 6 patty lines, the geometric length of stay, to represent the delay time. We ended up with a bar plot of the difference in time between the with and without consult group. Here we can see most of the yellow bars prove that even with the same diagonals, with consult will take more time than without consult.
Additional analysis was done to break up cases by physician and by physician specialty. So this is going to be used by the hospital administration to build standard practices based on the best performing physicians and the best performing physician specialties. So we can learn from the better performing groups here and also look at who's performing the worst compared to the CMS standards and look for reasons why they might not be meeting those standards. Also, a prediction model was built. This is more of a proof of concept, but the idea was to take early available variables for patient cases and better predict the expected length of stay for that patient. So planning can be done for that patient's discharge with better accuracy and ahead of time. As more variables are recorded, we'll get a better understanding of when that patient will be discharged and be able to provide more accurate estimates. Recommendations for the hospital is to put standardization processes in effect for physician consults to improve the quality of data and to reduce process variability. Additionally, lab and radiology orders should be able to be scheduled for patients in the hospital pending their discharge, and patient placement in elevated care facilities should be predicted using an AI model to better provide additional time for discharge planners.